I am testing the VU2 EVQ linear board after removing Cermet potentiometers and the MOSFETs because I had shown a short earlier. See? So it's still short. That means there is some problem in the circuit which I have assembled. Either there is some solder bridging or one of the components have gone bad. Discussed with VU2 EVQ today, and he suggested removing the RF choke first. That is, first disconnect the RF choke and check if it is still having this problem. That means the problem will be in this regulator circuit. So I am going to check it sequentially. As the first step, I have disconnected one end of the RF choke so that it is no longer connected to the rail on which the output transformer gets connected. Even after disconnecting the RF choke and hence a part of the circuit, the high current of the PA is still persisting. Next, I sequentially disconnected three 0.1 microfarad capacitors, as VU2 EVQ had mentioned that even if you disconnect them, there won't be much problem. After that, I disconnected regulator IC 7805 and then 7812, each time sequentially checking for a short in the board as shown earlier. When I tested after removing the regulator ICs, there was a slight surge current initially. So I am trying to short the ends so that any capacitor which is charged would be drained. That's how you saw that when I connected the power, there was an initial surge current which was not there on persisted contact. Again, I am discharging the capacitor and again testing. You can see that there is an initial current which is not sustained, meaning that probably that's in the 2.5 milliampere range. Reason is that that 100 microfarad capacitor near the power supply connection is probably getting charged and discharged in this process. Check the current drain of the power amplifier board after reconnecting the ICs. This time I am using new ICs 7805 and 7812, and between two also I had tested. It is reasonable, so there is no short in the board now. In the next step, I have reconnected the RF choke to that rail, and I am going to test how much current is drawn by the power amplifier. You can see about 10 milliamperes of current is being drawn. That's what is expected as mentioned by VU2 EVQ. So I had a sigh of relief. Instead of the Cermet preset potentiometers which were removed, to multi-turn, that is the blue color one, these are the two, were soldered, and then the current drain was again tested, which was reasonable. Now I am checking the voltages after connecting 9-volt battery, that is the voltage at the drain, positive voltage. Again I am going to check at the supply voltage, that will be shown as again 9 volts because the supply is 9 volts. And next I am setting this is again on the other side, and this is gate voltage. Voltage at the gate is being checked. This will not be the final voltage because I will be connecting 13.8 or 12 volt battery. So there is not much of problem in these voltages. With the voltmeter connected to check the gate voltage, that is, this is the gate or the place where the gate will be soldered. That's where the red probe is kept, and I am turning the preset multi-turn preset potentiometer. You can see that it's really multi-turn. Even after several turns, there is very little change in the voltage. So it's a very gradual, time consuming process to change the bias voltage for this multi-turn potentiometer. Here you can see the output terminal voltage of the 7805 IC is being checked. It is 5 volts. I am again turning the multi-turn potentiometer. It's a tricky job because the screwdriver kept slipping on, but now you can see that after several turns the voltage has started gradually increasing, and you can see it increasing. It should go up to 5 volts. Finally, I have reached the maximum, that is 5 volts for the gate of one MOSFET. This is just initial checking. We'll have to set it back again. Now I have reversed it to the other end so that the bias voltage here is 0, and for confirmation opposite side there is some bias voltage because that has not been changed. The same process was repeated on the other side. Now you can see that the bias voltage is the maximum 5 volts on the other side, while this side it is 0 because it has been turned back to 0 position. Here also it has been reversed back to 0 volts by turning the potentiometer backwards, and now it is ready for the next step, that is fixing the MOSFETs. Couple of them have to be fixed using heatsink compound, insulator and heatsink. That will be the next step, maybe tomorrow or day after, because this was, even though it's a small video, it was a really tiring job.